Okay, hi. So for this video, we will be discussing integration by algebraic substitution. So from the topic suggests, so we will be introducing another variable no, in our integrand, and we will express the integrand in terms of the new variable so that the integrand can be easily integrated. There are also some integrands that are very difficult to integrate no, without using algebraic substitution. So it is important that we discuss algebraic substitution. Okay, so again, in algebraic substitution, so we will introduce a new variable. Okay, so say for example, our integrand is a function of x. Okay, so say for example, we have the okay, so say for example, we have the integral of f of x dx. Okay, so in algebraic substitution, so part of the function of x now will be expressed in terms of a new variable. So say for example, z. So let say some function of x, no, some x as a function of z. Okay, so whatever part of the integrand that is, so we will express that in terms of z. Okay, and then correspondingly we will also change the differential part, so the dx will also be replaced in terms of the derivative of z, okay, of the new variable. Okay, and then with that we'll try to work on the integrand, okay, until we obtain a form that can be integrated. So there is no definite rule for the for the algebraic substitution. So there is no definite rule. So I think the general rule is you select the part of the integrand no, which makes it difficult to integrate. Okay, so and then some of it can be learned by experience. Okay, so when you solve a lot of problems involving algebraic substitution, then one look at the integrand, you can already see, you know, what is which part of the integrand should be substituted. Okay, so say for example, we have the integral of 5y plus 4 all over square root of 5y minus 1 dy. Okay, so this integral is fairly difficult to integrate. Okay, so but I can but it's not impossible, no, to integrate without algebraic substitution. Okay, so but first I would like to solve this using the conventional, no, integration, and then later on we will be using algebraic substitution. So to solve this problem, so we have as you notice, it's fairly difficult. So if we separate the terms, no, so we will have 5y over square root of 5y minus 1 plus 4 over square root of 5y minus 1. So it's still quite difficult not to integrate, especially the first term, the 5y over the square root of 5y minus 1. So what we can do is, since we already have 5y here, so we can copy the form of the function inside the integrand. So we can express it in terms of, okay, so 5y plus 4 is also equal to, so note that 5y plus 4 is also equal to 5y minus 1 plus 5, right? Okay, so we can express that as 5y minus 1 plus 5, so dy over square root of 5y minus 1. Okay, so if we separate now the terms, so we will have integral of 5y minus 1 over, so we can express 5y minus 1 in the square root in terms of exponent, so we will have 5y minus 1 raised to 1 half, and then dy. Okay, so plus, so 5 dy, integral of 5 dy over square root of 5y minus 1. Okay, so with that, so we can actually simplify this. So this will become integral of 5y minus 1 raised to 1 half. Okay, and then this will have integral of 5y minus 1 raised to negative 1 half, and then 5 dy. Okay, so integrating this using the general power formula, so we have our u as 5y minus 1, n is equal to 1 half, therefore our du, the complete differential of u, which is 5y minus 1, is equal to 5 dy. So we have we lack 5 here, so we will have 5y minus 1 raised to 1 half. Completing the differential, it should be 5 dy. Okay, so since we wrote 5 here, then outside the integral sign we will put its reciprocal 1/5 plus, so we have here already complete differential, so 5y minus 1 raised to negative 1 half times 5 dy. Okay, so the differential part is already complete, so therefore we can proceed with the general power formula. So we will have 1/5 times, so we have here 5y minus 1 raised to 1 half plus 1 over 1 half plus 1, and then plus we'll have 5y minus 1 raised to negative 1 half plus 1 over negative 1 half plus 1, and then plus c. Okay, so simplifying, so we have 1/5 divided by this will become 3 halves, so we will have 2 over 15. So 2 over 15 times 5y minus 1 raised to 3 halves plus, so we have here over 1 half, so 1 over 1 half, that is 2, right? So 2 times this is 5y minus 1 raised to 1 half plus c. Okay, so this could be our final answer, but we can still we can still factor, no? So let us factor 2 over 15 and 5y minus 1. So what will remain here is 5y minus 1 plus we will factor 5y minus 1 raised to 1 half. Okay, so here what will remain is plus this divided by this is equal to 15. Okay, plus c. So we will have so we will have 2 over 15 times 5y minus 1 raised to 1 half times 5y plus 14 plus c. Okay, so that is the solution if we don't use the algebraic what you call this, so algebraic substitution. Okay, so but in using algebraic substitution, so again we look at the integrand, okay, and then we try to find the part, no, which makes it difficult to integrate. So we have again integral of 5y plus 4 over square root of 5y minus 1 dy. Okay, so let's look for the part which makes it difficult to integrate. So as you notice, the denominator, no, makes it difficult to integrate. So we might want to replace that with another variable using algebraic substitution. So if we let, say for example, z as the square root of 5y minus 1 okay, and then the y here and the dy here will also be replaced in terms of z. So we need to express y in terms of z. So squaring both sides, so we will have z squared is equal to 5y minus 1. Okay, transposing 1, so we will have z squared plus 1 is equal to 5y. Okay, and then dividing both sides by 5, so we will have 1/5 z squared plus 1 is equal to y. Okay, and since we also need dy, so we will differentiate. So differentiating this, so this will be 1/5 multiplied by the differential of z squared is 2z dz, okay, plus 1. So the differential of constant is 0, so therefore 2/5 z dz is equal to dy. Okay, so what we're going to do is we will replace y in terms of z. So we will have integral of so 5 times y. So 5, our y now is 1/5 of z squared plus 1. Sorry, 1/5 of z squared plus 1. Okay, and then plus 4 over square root of 5y minus 1 is equal to z. And then our dy is times 2/5 of z dz. Okay, so this will now become so we will cancel 5. Okay, so this will become integral of, so we have here 2/5, so let's write that outside the integral sign. Okay, and then we can cancel out z here, so z and z, so what will remain is z squared plus 1 plus 4, okay, dz. Okay, so that is 2/5 integral of z squared plus 5, okay, dz. Okay, so so this can be easily integrated, so that will become 2/5 integral of z squared is 1/3 z cubed, okay, plus 5z. Okay, so we finished integrating, so plus c. Okay, so we can still factor out z. Okay, and then let's also factor out 1/3, so we'll have 2/5 times, so factoring out 1/3 and z, so we'll have 1/3 z, so what will remain inside is z squared plus 5z divided by 1/3 z, that is 15. Okay, plus c, so this will become 2/15 z times z squared plus 5, okay, plus c. So since our integrand is expressed in terms of y, then our answer must also be expressed in terms of y. So substituting back y, so z is equal to square root of 5y minus 1, or that is equal to 5y minus 1 raised to 1/2. Okay, and then multiplied by z squared, so since we have here z squared, so z squared is equal to 5y minus 1. Okay, and then plus 15, sorry, this is 15, so plus 15, okay, plus c. So this now becomes 2/15 times 5y minus 1 raised to 1/2 times 5y plus 14, okay, plus c. Okay, so that's how algebraic substitution works. Okay, so we express the integrand in terms of another variable. Okay, and it's important that when we do algebraic substitution, so we select the part of the original integrand, no? So we select the part that makes our integrand difficult to integrate. So as we can see here in our example, so we have selected the square root of 5y minus 1. Okay, so that's how you do it. Okay, so as you can see, compared with the previous solution, so we have here our previous solution. So compared with our previous solution, so this one is easier, no, to integrate, especially this part here. Okay, so this is fairly easy, no, so easier to integrate. Okay, because we only have in terms of one variable and simple power formula. Okay. Okay, so by the way, let's solve this problem again. Okay, so say when we substitute z, what if we did not include the radical, okay, the square root? So I'm writing the problem again, integral of dy plus 4 over sorry, what did I say? So integral of 5y plus 4 over square root of 5y minus 1 dy. Okay, so what if we only let our z as 5y minus 1? Okay, we did not include the radical, okay, the square root. So our y would become, so z plus 1 is equal to 5y, and then 1/5 of z plus 1 is equal to y. Okay, so therefore our dy is equal to 1/5 of dz. Okay, so substituting, so we will have integral of, so 5, so multiplied by our y is 1/5 of z plus 1. Okay, and then plus 4 over, so since only 5y minus 1 is z, therefore this will be over square root of z. Okay, and then multiplied by 1/5 dz, okay, for dy. Okay, so we can cancel 5 here, and then we will be left with, so we have 1/5 here, so we'll have 1/5 integral of we'll have z plus 5 over square root of z is z raised to 1/2, okay, times dz. Okay, so distributing z raised to 1/2, so this will become 1/5 integral of, so z divided by z raised to 1/2, that is z raised to 1/2, plus 5 divided by z raised to 1/2, that will be 5z raised to negative 1/2. Okay, dz. And then so we can proceed to integration, so this will become 1/5. We have z raised to 3/2 over 3/2, okay, plus 5 times z raised to negative 1/2 plus 1 over negative 1/2 plus 1, okay, plus c. Okay, so this will now become 1/5, so this will become 2/3, right? So z raised to 3/2 plus, this will now become 10, right? Z raised to 1/2, okay, plus c. Okay, so we can factor out 2/3 and z raised to 1/2, so we'll have 1/5 and then 2/3 z raised to 1/2. So what will remain here is z plus. So 10z raised to 1 half. Sorry. 10z raised to 1 half divided by 2/3 z raised to 1 half, that is 10 divided by 2/3, so that will be 15. Okay, plus c. So substituting back z, so this will become multiplying this, so we will have 2 over 15. Sorry, that should be z is 5y minus 1 raised to 1 half, and then z is 5y minus 1 still, so plus 15. Okay, plus c. So this will become similar with our previous answer, 2 over 15. 2 over 15 times 5y minus 1 raised to 1 half times 5y minus 5y plus 14 plus c. Okay, so still the same with our previous answer. Okay.